Second topic in this presentation, precipitate reactions. So here we go. We have a solution of sodium chromate. That's this one over here. It's a colored solution. You notice it's clear. All solutions are supposed to be clear. And it's added to a lead nitrate solution, which is here, also clear. Looks like water. And we're getting this solid formed. Now what's the solid? So you have to identify what this is. And this kind of solid is called a precipitate. That's a precipitate. The precipitate is a compound that's a product of a reaction, and it doesn't dissolve all the water, so it's insoluble. So let's figure out what is this yellow stuff. So we start off now with the names of our two reactants. Now, when you put these compounds in water, the water dissociates these ions from each other. So you really have four separate ions, four separate types of ions dumped together into the same container. So we can have some new combinations formed. But each combination has to have something positive with something negative. So the sodium can combine with the nitrate, and the lead can combine with the chromate. What could not happen is the sodium combining with the lead. That would be two positives coming together. Or the chromate combining with the nitrate. That would be two negatives. That wouldn't happen. So therefore, our possible products are these two. And out of these two, one of these is our precipitate. It's either sodium nitrate or it's lead chromate. Now, if you recall in the solubility rules, it said all sodium compounds are soluble in water. So it shouldn't be this one, it should be that one. But we can verify that. So we're going to then write three different types of equations. You're going to have to use these ions and their charges to write the equations. We're going to use the solubility rules to identify the precipitate. And again, we figure it should be the lead chromate, but the rules will just verify it for us. So here are the solubility rules again. And here are chromates down here. And you notice lead is not one of the exceptions. So that's our precipitate. So the first kind of an equation is called the molecular equation. And it's your standard chemical equation. We're going to write the formulas for all four substances. We're going to use AQ to indicate those that are soluble in water, and S solid for the precipitate. So here we go. So sodium chromate, two sodiums to the one chromate because of the charges. Sodium is only +1, and chromate is -2. Soluble in water, lead nitrate, same thing, soluble in water. Here's our lead chromate, again, +2 for the lead, -2 for the chromate, that's why it has that formula. Solid, so this is our precipitate, and that's going to indicate it, that is the precipitate. And then we have our other products, it stays dissolved in water, we don't see it, the sodium nitrate. If we ever wanted to get the sodium nitrate out of that, we'd have to filter out our precipitate and then evaporate the water to get the sodium nitrate. The next type of an equation, we're going to write these substances not the way we wrote them here, but as separate ions. So you notice we have sodium ions and chromate ions rather than writing it Na2CrO4. And now this 2 that was as a subscript is now a coefficient for the sodium. And here's the lead nitrate, and again, two nitrates. Here's lead and two nitrates. That 2 that was a subscript becomes now a coefficient. Our precipitate is written the same way it was written up here, no problem. And then we're also taking our other product apart, 2 sodiums and 2 nitrate ions. So this is a lot to write. Now from the ionic equation, we can come up with what we call the net ionic equation. Net, it's like a net peg. The net ionic equation will only show the precipitate being formed. So this is going to be our only product. And therefore we don't need the ions that didn't combine to make this. So then it would look like that. So here's our lead and our chromate, and that's lead chromate. Again, all equations must be balanced. But what about those other ions? Well, they're called spectator ions because they don't do anything. And we eliminate the spectator ions from the ionic equation when we write the net ionic. It's a lot to do, so you want to go slowly. Maybe you want to go back over this. So I'm going to give you one to do on your own. Okay. So here we have one for you guys to try. I have a beaker that contains 2 solutions, and we can see a precipitate is being formed. I'm mixing together silver nitrate solution and potassium chloride solution. So here are my questions. What's the precipitate? You want to use the solubility rules for that. And then I want you to write a balanced molecular equation, a balanced ionic equation, and a balanced net ionic equation. So we want to do that now. So pause at this point in time and try to write it before you check out the solution. Okay, here's the solution. So we go to the chart, and you notice I look up my ions. Silver chloride is going to be my precipitate because silver chloride is insoluble in water. Okay, so I get that identified. That's my first question. Now I want to write my equations. All right, so my first equation is my silver nitrate, and my potassium chloride is my silver chloride precipitate and my potassium nitrate. My ionic equation, I just simply break everything up into the ions. My 4 ions here is my precipitate again, is my potassium and my nitrate. My net ionic equation is not going to include the potassium nor the nitrate. It's just going to show the silver chloride being formed. And here it is. So my spectator ions, if I had been asked what they were, my spectator ions would be the potassium and the nitrate, because you notice they look exactly the same on each side. And that's the end.